All right. This green here that says currently there's no, and this is in the way, but currently there's nothing going on. When I look at that, then I go, okay, well, today might be a good day for propagation. Currently there's no noteworthy space weather. Last night there was. We had an X flare. How many of you know the flares? C, M, and X. C is the least worrisome. M is the next one, and then X. When you have an X flare, it tends to ionize the D layer and layers of the atmosphere. The D layer, E layer, and during the day there are two F layers, F1 and F2. When you have a solar radiation storm, not a geomagnetic storm, but a solar radiation storm, what happens is it super ionizes the D layer. And when that happens, when you operate your HF radio, that HF signal has to go through the D layer to get to either the E or the F layers. Now, if the D layer is super ionized, then it absorbs that signal and it does not let it go through. So basically it kills your HF at that point. When that happens, usually you'll have a type 2 emission warning that basically says a radio blackout and it'll have certain areas. And when that happens, can't fight it. You just got to sit back and either wait for it to stop or, deal with it. Now, it doesn't kill everything, but it does kill everything in certain areas. For instance, it may just be the polar regions, Alaska and things like that. But a couple of weeks ago, I was running FT8 on 20 meters, and I was getting 15, 20 decodes, and then all of a sudden, nothing. I mean, absolutely no decodes at all. So I brought my Space Weather Live up and found out that we had a major X flare, probably a magnitude of 6.1 to 7, which is pretty high. But then it'll show you a graph of the areas that are affected. There's a big red blob over the United States, pretty much mostly from probably Oklahoma northward all the way up through Canada. Nothing was happening. We had a radio blackout for about 20 minutes. And then once it's gone, my 20-meter FT8 came back up and I was getting 20 and 30 decodes again. So it happens. But if you're sitting there and you don't understand what's going on, you may go, God, my radio quit. Do I have to buy a new 7300? Oh, help us. Or is my antenna connected? So you run outside and make sure everything looks good. Well, you don't have to do that. You look at Space Weather Live, you can tell all that's going on because it will tell you. So then you can look at the sunspot regions. Can you cursor up a little bit so we can see this part here? And then maybe click down on that. Okay. This is an actual picture of the sun that's taken by these guys that run this website. And then they number the sunspot regions. They're probably, well, I guess you can read them, but they will tell you how many sunspots you have and the region. So here's region 3391, and currently there's one sunspot. But you go to 3395 and it shows 11, and then it shows the beta stuff here, which tells me that this area is probably responsible for a solar flare or a CME. How many know what a CME is? Coronal mass ejection. It's where the sun just explodes and sends out plasma out into space. Now they have, can you cursor up to this one? Okay. They have a satellite up there. It's called the SOHO. And the SOHO takes a disc in the middle of the camera, and it blocks out the entire sun except for the outline on the outside on the limbs. And they can tell whether or not this is Earth directed, or whether we're going to get a glancing blow, or whether it's not going to affect us at all by looking at this diagram or this picture. Currently, this picture shows that CME was a halo. What does that mean? That means it's probably going to be Earth directed. So what does that mean to us? Well, depends on how strong it is. It's carried by the solar winds. The solar winds about 500 miles a second. So it doesn't take too long. You're talking 93 million miles away. But it takes about 2 days before that will get here. When that does get here, depending on how strong it is, you have, click on this one, Mark. SOHO. Tells you what SOHO is. It's the Solar and Heliospheric Observatory. And it's a satellite that sits out there. And it has what's called LASCO, Large Angle and Spectrometric Chronograph. And LASCO takes a picture of it. And then the solar freaks, like Tamitha Skov and some other folks that are, way more crazy about this stuff than I am. But they look at it and they can tell whether or not that CME is actually going to hit us or whether it's going to get a glancing blow. If you watch, anytime you go out here and you watch this picture updates like hourly. So they'll get another picture hourly of what it looks like if there's any CMEs. And a CME, they can happen frequently. You may get 1 or 2 a day. But in 1940, just an example, in 1940, in March, there was 2 CMEs, very strong CMEs that happened within 1.8 hours of each other. And that was before transistors, so we got lucky. But the telegraph operators that were sending Morse code back and forth between the train stations and so on and so forth got shocked when they touched their key, because they were getting voltages about 600, 700, 800 volts. And that's just from a CME spaced out 1.8 hours apart. Very strong. So what would happen today? Yeah. So we would have issues if that happened today. Now, we have had some strong ones. 1989 is the most recent, the blackout of Quebec, Canada, and the parts of the East Coast of the United States were blacked out from 2 to 8 hours. So it happens. And that wasn't as strong as the one that was in 1940. So if you have something like that, it's going to disrupt things pretty nasty. So watching this, go back to the previous page, Mark. Thanks. So that's SOHO. And astronomers will use this to gauge the strength of the CMEs. Now, what does a CME really do? How does it affect the Earth? It affects the Earth. It's nothing but a big plasma storm. And it contains radiation and so on and so forth. Well, we're pretty much protected here on Earth by our atmosphere called the magnetosphere. So, but what happens is when that CME directly towards Earth, our north and south poles, like a magnet, it points towards north, yada, yada. Sun is the same way. But when the CME gets here, it has a tendency to reverse the polarity, which allows a hole in the magnetosphere so that the radiation and all that other stuff can get in. But it's so weak that we're not really affected by it. But I will tell you this, if you have a solar flare and you're a space cadet and you're up in the space station, you're pretty much protected because they have layers of protection inside that space station that protects them from radiation. But if they're outside doing trying to fix something on the outside and they have a very strong CME, they're going to be vulnerable. They're going to get some radiation. People that fly, if you're in the air in an aircraft going from point A to point B and we have a CME, this site will tell you that, oh, well, if you're an airplane and you're flying an airplane right now, we have a CME, don't worry about it. You're not going to get a lot of radiation, but you're going to get some. And this site will tell you that. So this is one of the biggest things that I watch. I do a lot of FT8. How many of you do meteor scatter? Anybody played with Perseids this morning or last night? I made a QSO this morning into Illinois on 6 meters using meteor scatter. And this site's not going to tell you a lot about meteor scatter, but other sites will. Only reason I mention it is because when meteors pass through the E layer, they burn up. That's why you see the trails and all that stuff. And when they do burn up, they cause ionization in the E layer. And as you transmit your signal up, it could hit one of those hot spots, as I call it, and reflect it back down to Earth, and you make a QSO. Now, this morning, my QSO into Echo November 41 took 3 minutes. From the time I answered his QSO till the time that he gave me a 73. It has taken 2 hours or more. So meteor scatter is a very viable thing, but it takes patience. Is it going to tell you on this website? Probably not. But what this website is really for is to clue you in on just exactly what propagation is happening, what's going on. What am I looking for here? Go back to the beginning, Mark, if you would. Okay. Go back to the next one on this one. Right here. Next one. That's good. Go here. This was on the 18th of July, and we had an M5.7 solar flare. It's not as significant as the one we had a week and a half ago. Because we had, the class of solar flares, C, M, and X. We had an X, probably X 7.1. It's pretty significant. And like I said, those things don't last that long because it takes them once they eject off the sun, it takes about 2 days to get here or longer, depending on how fast the solar wind is. And all the solar wind is the plasma and the gases and all the radiation and the protons and the electrons that are emitted off the sun are spewed out. Depends on where the flare happens. If it happens on the limb, more than likely it's not going to be Earth directed. But if it happens towards the center of the sun or, not on the limbs, either the east or west limb, then they're pretty uneventful. Okay, go to the auroral activity page. Is there a mark? Are there any questions on solar activity right now? Yes, sir.
Solar panels, photovoltaic. years ago, I had a course, and we had a standard of about 1 kilowatt per square meter of energy. How does that fluctuate with total flux, that part of the spectrum? I know that obviously we're dealing with a broad spectrum and a lot of it's absorbed, but what's the impact of flux is more than double what it was 3 or 4 years ago?
Oh, yeah, yeah.
That relates to electric energy.
Well, now we're talking solar cycles. You know, solar cycle is about every 11 years from minimum to maximum. Right now, we're getting towards the maximum for cycle 25. Now, as far as solar panels are concerned, I don't know that much about the solar panels, about how the sun affects that, other than, you know, it's going to take the energy from the sun and it's going to create, you know, voltage. But as far as solar flux, the solar flux itself, right now we're at about 160, I guess, whatever it is, 156. And it's probably going to go up into the 170s in the coming week. It's been about 3 months ago, we were up above 215. Now, in order for, how many 6-meter DXers do we have in here? 6-meter DX is mostly sporadic E from about June to about the middle of August. Now, sporadic E differs than regular E layer stuff because it's sporadic. And what happens is that the atmosphere gets ionized and it creates clouds. Now, they're not clouds like you would see, you know, on a cloudy day, the white puffy clouds, because they're probably transparent. But what happens is the sun ionizes an area in the E layer and it causes small little clouds. Well, as you get closer to June, actually it's May through about August, you get closer to June, you start getting maximum number of sporadic E cloud days. And go to N0, what's that guy's name that does that stuff?
HHT?
No, Paul Herman. Go to his website.
NBH.
That's it. That's the one. Now, here's another website that might interest you. And this guy's got a lot of solar data. Scroll up, Mark, to this predicted solar data area. Okay, back down a little bit. Right there, right there. He has some pretty good stuff on this website, but as you can look, he has, is that the right one? Yeah. He has all this stuff up here that you can look at. Solar flux index for today is 153. The alpha index is 5, kilo index is 1. How many people know what we're talking about? Alpha and kilo indexes. Don't, you're afraid to raise your hand, are you?
Keep going.
The alpha index, well, let me start with the kilo index. The kilo index is an average, a 3-hour average of geomagnetic activity, meaning they have these magnetometers stretched across the planet that look at magnetic activity across the earth. And the kilo index is a 3-hour average of that number. A kilo index of 0 is nothing. Up to 3 means that the magnetic field is quiet. When you start getting above 3, like 4, 5, and it goes up to 9. So 4 and 5 would be strong. 6, 7, and 8 would be moderate, and 9 would be extreme. So what does that mean to us? If you have a magnetic storm that's a 9, which I don't think I've ever seen one. I know we had an 8 here earlier this year. But an 8 will allow you to see aurora in Oklahoma. So looking at this website or anything that will show you what the kilo index is, the alpha index is the kilo index is logarithmic. The alpha index is an average that's equal pretty much to the kilo, only the numbers are different because they are linear. So if you look at an alpha index and it's 5 and a kilo index is 1, geomagnetic field is quiet. There's no storms going on. So your HF should be good. If you got an 8 on a kilo index and the alpha index is like 125, 135, 140, you might as well go to UHF, VHF because HF's not going to be very good. It's going to be very noisy, a lot of static and stuff. But the X-ray portion up there is a C 1.1. Remember, the C is the lowest on the X-ray scale, solar scale for solar radiation. Then we have, okay, go to that, see where it says. Okay, the B sub Z is, if that's a negative number, that means that the solar wind carrying a CME or whatever has reached the Earth's magnetosphere and it is south. It is trending south. When that happens, you've got a solar storm going on. If it's large, that's not too bad. It'll probably go back positive later on in the day. But stuff like this, in a solar wind, it's 425.6 kilometers per hour. So that's pretty quick. But sites like this and sites like, what's the other one? Yeah, QRZ has one on there, but, and you can, if you have a website and you want to place this stuff on your website, this is the site to go to because he gives you the code to do that. Go back to Space Weather Live. And the aurora activity. Yeah, the first one, yeah. It shows you the current kilo index. So here that is, it's, it used to be they only did it in increments of 1, but now they're getting a little bit more down to the nitty gritty. So this is like 1.2, whatever it is. But it's updated hourly, even though the average is every 3 hours. So this may stay that way for the next 3 or 4 hours or whatever. But like I said, the latest news, it will always show you what the latest news is. And then if there is a storm and the kilo index is, let's say it's 7, then this auroral oval, the green areas, will show you where aurora is taking place right now today. So keeping this particular page up, you'll know whether or not you have a geomagnetic storm. You get the latest news, and then up top, that green may turn to an orange color that says solar radiation storm, a minor S1 storm. S1's not too bad. S2, S3, and it goes up to S5, S6, I think. But as you get those more larger storms, then the up top where the green, where it says currently there is no noteworthy space weather, they will tell you what's going on. They'll either say a type 2 radio emission blackout, radio blackout, or it may say S1 solar radiation storm or an S2 storm or whatever. And if it's really critical, they will give you warnings, and then you start watching other things and you go back and forth to the kilo index. And if you got a kilo index of 7 or 8, 6 meters and 2 meters and 440 would probably be open somewhere. But HF wise, probably not going to be real good. Last week when we had the bad X-ray storm, the green area was actually red or blue, and it was actually over most of the United States and most Europe. So we were having some real issues. Like I said, we had a radio blackout, at least for me, for at least 20 minutes, maybe longer, where I had nothing. I went from 10 meters all the way down to 80 meters and nothing. Now, I will tell you one thing. We all know that 80 meters during the day is not a good band to be on. Why is that? It's because during the day, the D layer gets ionized by the sun. And the more ionization, the higher the frequencies it will stop. Well, low frequencies, i.e. 80 meters, will not pass through the D layer during the day. And that's the reason. It's the reason why 80 meters is not a daytime band. At night, the D layer goes away. There is no D layer. So 80 meters becomes a good nighttime band. And you go to the solar activity area again. Real-time solar activity. It will tell you, scroll down, Mark. Maybe it doesn't. But it will give you an idea of what bands are open, what bands aren't. So you can pretty much take this website Where are you going?
He's wanting to go to QRZ.
Oh.
They actually tell you the bands.
Yeah, and so Paul Herman's website, he's got all that stuff there too. But QRZ has matter of fact, QRZ has the same graph that Paul Herman provides, and you can just plop that up on your website. Oh, you have one here. Yeah, okay. So this one shows, is this current? Yeah, 12 August. So this one shows right now that there is sporadic E going on in Europe. How many of you use PSK Reporter? PSK Reporter is a pretty neat website. It will tell you who's working who on what bands. And it will show you a picture. Are you going there?
Yep.
Good man, I'll tell you what.
You gonna pay me more?
Yeah, okay. PSK Reporter, you tell it what you want to see pretty much. There's the IT guy. Here we go. All right. And go to the map display. Yeah. So up top, say we want to watch 6 meters, Mark. Okay, there we go. and then choose signals sent received by the call sign, put, doesn't matter. And all modes, no, let's go to FT8. And then for the last 6 hours. And click go. This is all the FT8 activity on 6 meters that's going on right now. And you can see that there's a lot in Europe and in the United States. Probably most of the stuff in the United States is just listeners, because I doubt that they're working anybody in Europe, but this will give you a good idea of who's doing what to who on 6 meters. And you can do that for any one of the bands. And then you click on one of them and you can go show all seen by KW4YA. Now this is everybody he's seen in this cone. So you can look at that and go, oh, okay, well, maybe 6 meters might be something good to go to. I use this a lot. Yeah. Let's go back to space weather real quick. Any questions so far?
When you said you had your blackout, how soon from you had the blackout, how soon from that blackout to you saw something here that you recognized? Is that first, or were you first when you noticed it?
Well, as soon as I noticed that it went from like 12 or 15 decodes to nothing, I said, well, I know it's not my radio, and it's probably not my antenna. So then I go here first. The first place I go to.
Was it there already, or did you wait 30 minutes?
Oh, no, it was already there. Yeah, it basically told me that we had an X-ray flare about 6.1, I think, was what it was. And then underneath that, it was a type 2 radio transmission blackout. And then there was something else. But then I knew what was going on. Once you looked at this for a long time and you've got it up running all the time, you're probably going to want to keep it there because it's pretty informative. Any questions? Yes, sir.
So in April of next year, there, you know where I'm going there. There is a total solar eclipse that will occur, and part of the path of total blackout will be through southeast Oklahoma. How will eclipse affect any space weather and propagation during the time that it affects?
Probably won't.
It should cool the atmosphere, right?
Yeah, but heat is one thing, yes. But I have, and like I said, I'm I'm obviously not Tamitha Scove. Lucky you guys. So I don't really know, but I would guess that because I do a lot of reading, and the last eclipse we had, some of the amateur radio operators were saying, well, hey, I didn't notice anything different. It got dark, in my area, but propagation was still good. So I really don't know, honestly.
Actually, the totality is only like 4 minutes.
Yeah. But I'll do some more reading, and next time I come out here, I'll tell you what I found out. But I don't think it's going to do anything. Any other questions?
Just as a follow-up, if you Google HAMSCI, HAMSCI, and eclipse, they did a study on the last eclipse where HAMS was reporting what they saw for propagation, and they did some quantification based on the PSK recorder kind of sites. And they showed what happened, so I'm sure Hansai will do it again for this next one coming up, but they had some observations there that showed what it was.
Okay, cool. Any other question? Short and sweet, but that site is a really good site for those of you that do DX. Those of you that, are just an occasional, you probably don't have to deal with it, but it's on my computer all the time. And it's really helped me out in various things.
Duane, is there any time that you should unplug a radio based on these numbers? That it's damaging to equipment? Do they offer any guidance on a 9, you unplug everything, or?
No, the only time I unplug is, lightning storms. But I don't think the amount of solar radiation that gets into the earth is not enough to do with anything. Now, EMPs, that's different, but that's kind of what the solar radiation is like. But if you get if you had a strong storm, CMEs that were back to back within hours of each other, I don't think our power grid would handle that very well at all. And I don't know about, because if it gets in and it affects the power grid, it's going to affect everything else that has, that's running, whether it be DC or AC. So, transistors and stuff like that. We didn't have that issue in 1941. 1989, they did. And you can see what happened in 1989, where Canada, most of Quebec, Canada, all the way down into the northern tier states and the East Coast were blacked out. So.
Always a good reason to have your battery backups ready.
Yep. That's all I got.
All right. Thank you, Duane, for that
Sure.
program.